Hi, do you like programming?
Yeah,
Do you like making computers your slave?
total.
Do you like torture?
Yeah. Oh wait, what? Assembly. It's like a language, alright? But like, it's like English, but it's not English, it's Chinese. And it's actually a secret agent out to kill you because you speak it. Yeah. Well, that doesn't tell you much, so here are more details. It's the year 1947. Side note, I did not expect for it to be this old, but it is in fact. And some scientists are faced with a problem. They were lazy. Coding was hard back then. They didn't have an AI to assist them on every small error, and they needed to speak a computer language. What is computer language? Well, it looks like this. It's binary. PCs can only read ones and zeros as instructions, and coding was tiring and hard, often requiring programmers to punch their numbers into cards. So, some developers thought, why don't we torture ourselves and make more people able to torture themselves, but lighter? And so it began, development on assembly. Its goal? Simplify development by making it more English-like. But English-like kind of kills it already because, oh my god, it's still cryptic. Now, back in the day, almost all programs were in fact made in assembly. But over the years, it has been largely replaced by more higher level languages like C and C++. Comparing assembly to C is like comparing a children's book to a novel. A 1,000-page novel, written in a language you don't understand. Guess which one is which? But why exactly is it so hard to learn? Well, it's because it's not a language, it's a goddamn secret agent. No, seriously, it's a secret agent. A secret agent of the computer world. It's like a hidden message that only the computer can understand and some unfortunate programmers. And to translate that message, you need to know the code, the architecture, the instruction set, more on that later, and the way the computer processes each and every instruction. It's not just knowing how to write code in assembly, it's about understanding the underlying mechanism of the computer. And if you're not careful, assembly can kill you. No, not literally, but it can make you want to switch your profession. One small mistake in your code can result in a crash, or even worse, silent failure, because it is that petty. The computer won't tell you what's wrong, it'll just give you an error message, and finding that error is like sniping an enemy in CSGO with a shotgun. If you ever tried that, you will know it's impossible. Now I can tell you that assembly is still used to this day. Of course not as much as it used to, as programmers are becoming less and less masochistic, but it still has its use cases, especially in programs that need to be small and fast. What comes to mind are programs that start your computer, so-called bootloaders. But of course I have to talk about why anyone would want to learn assembly today, except of course, honestly, I don't know, I guess to brag? Oh, wait, I got it. Learning how computers work. Yes, that is kind of like using a truck to transport your puppy to the vet. But hey, it's still a truck and it will get the job done. Now, I'm not going to teach you how to code in assembly because that will take a lot of time. And I'm not sure if you would even want to learn that. But I will teach you how to read assembly code because that's a lot easier and you can learn a lot from it. So let's start with the basics. The first thing you need to know is the instruction set. This is the set of instructions that a computer can understand. For example, the x86 instruction set has instructions like move, add, subtract, and, or, XOR, etc. And each instruction has a different purpose. For example, move is used to move data from one place to another. Add is used to add two numbers, and jump is used to jump to a different part of your code. Now, the next thing you need to know is architecture. As if assembly wasn't cryptic enough, There are different architectures for different computers. For example, x86 is the architecture for the Intel x86 processors, like the ones we have today. Well, actually, the ones we have today are x86-64, which are upgrades to that. And another example is ARM, the architecture for the ARM processors, like the ones your phone probably uses. And each architecture has its own instruction set. So if you want to write assembly code for a computer, you need to know the architecture of that computer. You finished writing your beautiful code and want to run it on a different computer? Well, you're going to have to rewrite it, because the instruction set is different. Yes, have fun with that. Let's look at a basic program to print out Hello YouTube on screen. Here's the code in C. Integer main, printf Hello YouTube, return 0. And here's the code, how it would look in assembly. Section data, message, database, Hello YouTube, 10. Section text, global, start. Start, move 1 to RAX, move 1 to RDI, move message to RSI, move 13 to RDX, syscall. Before you shout, what the hell is this? Let me explain. In this program we print Hello YouTube, just like in the C program, but we do it in assembly. And we do it in a way that is compatible with the x86-64 architecture. So let's break it down. First, we have a section called data, where we store the data that we want to print. In this case, we want to print Hello YouTube, so we store that in the message variable. And we also store a new line character at the end of the string. This is because we want to print the string on a new line, and the new line character is 10 in ASCII. Then we have the section called text. This is where we store the instructions that we want to execute. And we also have a global variable called start. This is the entry of our program. This is where the program starts executing. Then we have the start label. This is where we start executing our code. We start by moving 1 to the registers RAX and RDI. This is to tell the system, hey, might want to print something to the screen. Afterwards, we move message, the one we said earlier, to the register RSI. This is used by the system to know what we want to print. Then we move 13 to the register RDX. This is used by the system to know how many characters we want to print. And finally, we execute the syscall instruction. This is used to execute the system call, in this case, the system call to print something to the screen. This is why assembly is so good for learning how computers work. You can see exactly what is happening in the computer. You can see the data being moved from one place to another. You can see the registers being used. And you can see the instructions being executed. So, what are more examples of assembly being used in the real world? Let's go back to the past with the Nintendo Entertainment System. Because of hardware constraints at the time, developers at Nintendo could not afford to lose performance to compilers, even if they existed at the time. The NES was cheap, so it did not have a lot of memory, and the developers had to make sure the games would run on the NES. So they had to write code in assembly, because it was the only way to make sure that the code would run on the NES in the most efficient way possible. And that's why the NES games are so good. They are so good because they were written in assembly, and assembly is the best language ever. Not. But it's still a good language in that use case. There you have it, a quick dive into the world of assembly. I hope you are feeling okay after this brain-melting experience. If you want to learn more about assembly, don't. I recommend you to try making homebrew games for the NES, and you can learn a lot about assembly and how computers work. See you next time.